If you saw my recent video on upgrading my backup camera system to the Furrion Vision S, you know that the 7-inch monitor is capable of 4 cameras, but I only put 3 cameras in. The rear camera, left and right camera. And there's a provision for a 4th door camera, which I elected not to use. I did purchase a door camera. This is a sharkfin camera that's compatible with the system, and this can be used for the door or the rear view camera. I bought this 4th camera for the system, however I'm not going to use it with the door. I'm actually going to take the housing apart, put the camera in a new housing that I 3D print, and use it for another purpose. We see that we have, this is the power cord, bag of parts, we have the antenna, and then, of course, we have the shark fin camera. We have to disassemble this. And the first thing we want to do is take out the 4 screws around the periphery and pull the gasket off the back. And the camera then comes out just as a module. And I've actually taken this apart already, but I'm just showing how you would do it. There's 4 more screws on the corners, and this back comes off. And then you have to loosen the nut here on the antenna, and then the camera just slides out of the front side of the housing. This is the only part that we need. And you know which is right side up and is upside down because of this little F. And I printed a 3D housing. This is just a concept to begin with, and then the production I'll print at a higher quality in black. Then we have the housing here, and we have a bracket. And in the production model, the differences are this slot will appear here as well. So you can use the camera right side up or upside down. So you can mount this housing like this or like this. And also, I moved in the production version the antenna mount to the back, so it's going to kind of look like a doggy tail, you know, it's going to stick out like this. I must have made about 6 different versions of this before I decided on one, and that's one beauty of the 3D printing. You print it in low quality, try it, if it don't work, you just print another one. This takes about 20 minutes to print. This one took about 11 hours, even in low quality. So the way this installs is this bracket will go either way, either this way or this way, doesn't matter. We simply put one of the mounts there and spread the plastic and put the other mount there. And there you go. That's all there is to holding on to the camera. And of course, with all my projects, if you go to my project webpage, you'll find expanded information, and I'll put a link here. You can also download the files if you want to print these. And also, I did a video on if you don't have a 3D printer, how you can still get 3D prints made from a printing surface. So you should have one avenue at least to be able to do this. And to assemble, the wires go into the slot. And that's why I had to cut another slot, is because if I put it upside down, then the wires wouldn't fit. And if you try to tighten them too tight, you can strip the threads. Then we want to put this antenna connector in. That just goes through the hole. And I didn't make any provisions for any further waterproofing. This has got a waterproofing gasket on it, so this should be okay. It's adjustable, just like the old one. So we want from a vertical mount to a horizontal mount. And I did mention this to Furrion as an idea when I bought my 7-inch monitor, that maybe they can come up with a different bracket to do a horizontal mounting. And they said, hey, that's a great idea. We'll have somebody look into it, but you know, how many months is that going to take? And when I print the production model, this is going to be black, and I'll probably even paint it. And here we have the prototype temporarily mounted to the pin box by the use of magnets. In fact, I think I will try the operational test with it on magnets as well. That way I don't have to drill any holes into the pin box until I'm sure of where it should be. And I also want to explore the possibility of mounting the camera inverted here. And here is a conceptual drawing of both the housing and the front bracket to mount the camera into the housing. And for my first test, I've placed this under the hitch, so it'll show me what it looks like from the underside of the hitch. And I've also marked the center point here. And again, this is on magnets, so I can move it around. You know, oftentimes it's hard to find just the right size switch box. Not anymore, when you can 3D print them. And this is one that I printed. And it's for a toggle switch, and we're going to use that in this project. And we're looking at the DC distribution area at the front of the RV, and you can see here I have my hitch cam camera switch, and I needed to power this separately from the rest of the cameras. If you recall, the rest of the cameras are connected to the running lights of the RV, and that's not really a good idea for this because of course you either need to have the truck already connected or some gizmo to turn the lights on with the running lights. Well, since we're going to hitch the truck with the hitch camera, we want to power this independently, so I have it powered just through my distribution panel here, and then that goes straight into the battery. And the wiring goes from the battery to the switch, through some cables, up through to the front, all the way around to where the pin box is. I get my Lippert remote control out, and we want to retract the front. And I'm just pushing on it. Okay. There we go, it's locked. How's that? And you'll notice here I'm turned almost, but not quite as far as I should turn. And where I put this mark here, I could put a corresponding mark on the fifth wheel plate. And as I turn, that will be kind of a point to tell me don't turn anymore, or I could smack the cab. So you see, even at that mark, I'm leaving myself plenty of space between the cab and the nose of the RV. And to do the next test, I have to change the orientation of the camera. Currently the camera is set up so that it is upside down, because when I put it on upside down it becomes right side up. And we've now repositioned the camera. One issue we have is when the camera is here, you can't see this very well. And it's a little more noticeable. Before, when it was stuck underneath, you didn't have to worry about anybody taking off with it. And since this is just on with magnets, somebody could conceivably swipe it, I suppose. And when you back up, we have to orient this little yellow mark with the center of the hitch so you don't have a viewpoint as you did before. However, you can see your truck farther away as you're backing in. So, it all depends on what you prefer. And like before, I turned the RV as sharp as I dare turn it, and I'm about a foot or about 9 inches from hitting the cab, and then I put a mark on the bed here that corresponds or lines up with the mark here. That way I'll never go beyond that, I'll never hit the cab. The original purpose of the door camera was as a security camera, and that you could monitor anybody coming up to your door, independent of using the cameras as an aid to backing up and changing lanes. Well, I can do the same thing with the hitch camera, and here I show looking out the front of the hitch. Now, of course, you can't see the door, but you can see the front end of your RV. You can actually take the camera and put it anywhere you want to put it, as long as you have a source of 12 volts and the steel surface that the magnets will mount to. And you can move the camera anywhere you want to move it. As I zoom out, I have the monitor just on a little platform in the inside of the RV. And so that's how you can bring the monitor inside. In fact, one of the original options for the Furrion camera is a wall bracket so that you can mount it to the wall of your RV on the inside. But you can mount this, on your bedstand or whatever and monitor the front of your RV or anywhere else you want to point the camera at. And if you're going to power the monitor on the inside of the RV, you need a source of 12 volts. This is made by Jameco, and I'll put a link to it. This is a wall transformer. However, this is a little bit heavier and different than most of the wall transformers you see. Most wall transformers are what's called switching transformers, where they actually send a lot of noise on the DC side. They're getting much better than they used to, but they still can do that. And this is a linear power supply, regulated voltage of 12 volts. And the main difference is this is much cleaner power